So welcome. I know this isn't an ideal week one online lecture. However, the truth is that at the end of the day I'm still a human with a family, and currently my family is in Sydney Hospital, so that's where I am offering some support. So hopefully this week is easy enough for you, particularly for this unit content-wise, and getting your head around all the administration, familiarising yourself with the unit outline, the assessment, getting a hold of the textbook and whatnot, and that you're busy enough with your other units so that you can understand, and forgive me for not being there as a face in this particular week, but I look forward to meeting you all face-to-face in week 2. So this of course is Exploring Mathematics 2. So there's two different groups that do this unit depending on your degree structure and whereabouts you are in that. What's really important is that you check Leo regularly for links, resources, updates. You'll find out which weeks are online. We'll have a few more apart from just this first week, and which ones are face-to-face. So this unit aims to improve your mathematical skills and confidence in a number of areas, including rational number, and rational number encompassing things like fractions, decimals, percentages, ratios. We'll also cover some stuff like algebra, statistics, probability, extends on knowledge that you've already gained from Mathematics 1, and your ability to work with whole numbers, which is something that you did do in Maths 1, and that's pretty essential for good skills and development through rational number, which is about half of this particular course. So a rational number is any number that can be written as a fraction. So obviously fractions are already fractions, but most decimals can also be written as fractions, and all percentages are fractions already because they're numbers out of 100. So that's where the term rational number comes from. So that's where we spend the first few weeks of this course. It's really important that every week you complete the set consolidation questions from your textbook. It's been a while for most of you since you did these kinds of mathematical questions. And like everything that's skill related, for example, if I'm a pianist, so playing the piano, it's a particular skill related to that, but the less I practice, whilst I still may understand the concepts and the ideas, the less fluent, accurate I am at actually performing. So it's the same with mathematics. So you may have not had practice at these sorts of maths questions for a number of years. You may have become less fluent or accurate. So it's really important that you spend some time completing the consolidation questions. Now, each week, starting from week 3, there's weekly tests on these particular skills. So the one in week 3 will be the skills that you've developing through this week in week 1, which is their revision of whole number. You've got a little bit of time between when we learn the concept and when the test is. That gives you the capacity to complete the consolidation questions and see me and ask for help. So if it's a particular topic that you've found difficult, make sure you see me in the workshop, either in that week or in the week between, and clarify those misunderstandings to give yourself every opportunity to achieve as well as you can in those weekly skill tests. Each week we have a 2-hour workshop, and that particular workshop will be split up into practical task, questions from the consolidation component, and a problem-solving task related to the week's topic. So one thing that's really important, and that you did touch on in Maths 1, and that it's still important enough for us to bring up again through Maths 2, is the idea of understanding the difference between mathematics and numeracy. There's always a fair bit of confusion when trying to draw this line between what mathematics is and what numeracy is. Now, I don't actually believe there is a single line. I think of it as more of a large blurred area. There's quite a lot of overlap, a lot of grey areas. I suppose what it comes down to, though, is that it's really important to understand what the Australian curriculum identifies as the definition of numeracy, particularly because this guides a lot of what mathematics and numeracy programs are actually run in schools. they're guided by the curriculum and the curriculum documentation and the language that supports that. So as a teacher coming into the profession, it's really important that you are familiar with that particular definition. So I encourage you to return to your curriculum documentation, familiarise yourself with your current definition, write it down in your notes for this unit, and make sure you're accustomed to also probably the Australian Association of Maths Teachers definition. Probably write them both down, identify where they're very similar and maybe where there's a little bit of ambiguous difference. This course focuses on your own mathematical skills and understanding, so all of the content we cover you will have covered in primary and high school yourself. Although some of the approaches I use might be different or unfamiliar to you, we're going to be going over the math skills for your own benefit and the numeracy concepts for your understanding and development. So, in my opinion, here's some things around mathematics. So, I do believe mathematics is a bit of an art. I believe it's very beautiful. It's an abstract notion, mathematics itself in its purest form. It has its own language and comprises of the skills, facts and conceptual understandings that underpin what we call mathematical work. So this is the doing. It's typically referred to as the science of patterns and relationships. Numeracy, on the other hand, basically the sort of the basic skills necessary for participation in life and work. It covers a range of topics, and numeracy is not just necessarily about number, and it's not just the easy maths either. So we have financial literacy, statistical literacy, which are all very basic numeric components. Have a little look, go back to your curriculum documentation, see what they say mathematics is, add it to these lists of ideas. See what they say what numeracy is, and add it to this list of ideas. So I just want you to do a quick activity. You can do this with a study partner or by yourself. The first thing is I want you to list 5 situations where you might need to be numerate. So we're thinking about situations. I don't want actual ideas about numeracy. Situations you might find yourself in real life that require you to be numerate. So just see if you can write down 5 different things there. Once you've got those 5 situations, then I want you to think about what basic skills are necessary to be able to complete that task or understanding or participate in that particular task. Once you've done that one, I also want you to think about 5 situations where mathematics would be used. And this is probably a harder question to answer. The numeracy one, hopefully you found fairly simple. But yeah, have a think about what 5 situations you think mathematics might be used. And we'll bring this up in our first face-to-face workshop in week 2. So this course also works through ideas around mathematical reasoning. And we incorporate this into each topic, but of course then you need to know exactly what is mathematical reasoning. So reasoning itself is a verb. It's the act of making justified arguments or reasons about a situation. Now mathematical reasoning is making these arguments using mathematical language and according to the rules or axioms of mathematics. So there's this foundation, there's this primitive layer of the most fundamental rules that we can use, and mathematical reasoning is that ability to use those to justify or make valid arguments. So mathematics is built upon these foundations called axioms, and they develop into the rules and conditions that we're used to operating with. So there's a very famous mathematician called Euclid, and he wrote what we could call the very first mathematical textbook. He was one of the first people ever to document all the axioms and rules for number theory and geometry, all the maths that was known in the day, he wrote down into a series of books. And they didn't have photocopiers or printers, of course, back then, so that particular book is called The Elements in Mathematics, and it got sent off to some monasteries where monks painstakingly copied page by page, and then they were able to distribute, or other mathematicians could come and purchase or trade or barter or borrow these particular books. So they became the first textbooks for mathematics. Now, communication of your mathematical ideas is really important, as is being able to explain your reasoning. So being able to use your mathematical language and explain your reasoning really strengthens your understanding of the mathematics. And of course, that's really critical if eventually you're going to go off and teach it. You need to have a really good understanding of it. So that's why we incorporate mathematical reasoning as much as possible into each of the different topics that we use. Now that's slightly different to mathematical thinking, but really if you step out, zoom out and think slightly big picture, you can put it under the one umbrella. Mathematical thinking is more about explaining the steps involved in your questions. It's like your line by line working. The mathematical reasoning is the big picture argument, the reasoning, the justification that you're making. Mathematical thinking is your line per line, actual writing out what it is and how one step gets to the next and so on. How you get from point A to point B, if you like, following the instructions that you map out. So reasoning is more abstract, big picture, your ability to construct logical arguments, whereas thinking is the ability to turn that argument into mathematical working. So one, I suppose, is the topic of your essay, and the other are the sentences that construct it. So in Maths 1, you did some work in whole number, and whole number underpins a lot of the beginning of where this unit goes into rational number. So whole numbers, like the counting numbers, they start at 1 and just go onwards, 1, 2, 3, 4, and onwards. We can add a 0 to that, although it's not necessarily a number, it's more like an absence of a number. It was one of the last numbers to be added to our numeration system, in fact. And we can also think about negative numbers as being the opposites of our whole numbers. So altogether, whole numbers and negative numbers, they make up a number system, or a group of numbers that we call integers. Now, these particular numbers, whole numbers and negative numbers, they do form the groundwork for which most of our practical mathematics is built. We can't measure or calculate or barter or trade, purchase, we can't farm, create or design or program without our basic numbers, whole numbers and negative numbers. So this week it's really important that you spend some time practicing your whole number and integer skills, including some components of number theory, all of which you did in Maths 1. So whole numbers in our Roman numeral system are built on a repeating pattern of 10 digits. We've got the digits 1 through 9. We also have the digit 0, so there's 10 digits there. And we have a place value system that uses base 10, and that gives us the ability to construct large numbers easily. That particular topic is described in one of your online videos for this week. There's a link for that on the learning brief on Leo. So skills, these are not operational skills. These are things that you just need to be able to do with numbers. So you need to understand our place value system. It's base 10. You need to understand how it works, what the columns are called. You need to be able to write numbers using digits. So if I said to you the number 6,055, you could write that down as a number. You need to be able to understand the role of 0 in writing numbers. So if we think about what 6,055 looked like using digits, what is the role of 0 in that number? You need to be able to write a number in words. Where do the ands go, and how do the ands and the pauses in saying a number relate to how it looks using digits? And you need to be able to write numbers in expanded form. So all of those skills you can find when we get to looking at the textbook for this particular week. You can do some consolidation and revision on those areas. We also have 4 operations with whole numbers. The first is addition. So, whilst it might sound simple, addition is a pretty fundamental concept. We spend years developing it in primary school. from it builds the concepts of multiplication, and without it we don't have a number system. So it's a really important skill. So have a think about these following questions. I'm just going to go over those questions very briefly. So can you add mentally 2 and 2-digit numbers? This demonstrates that you have flexibility and fluency, you understand our place value system, and that you can regroup effectively. Do you have 3 different ways of adding numbers? So these could be number lines or empty number lines, regrouping, using algorithms, break up, make up, other sorts of notations. It's really important that you know at least 3, preferably more, 5 or 6 different ways to be able to add numbers. And you might have different methods that are suitable for different types of numbers, single digit, double digit. Something that's just really important for you to know personally is how much can I do comfortably in my head using a pen and paper, and then when do I reach for a calculator. Sometimes the purpose and the level of accuracy that's needed in the answer can be your answer to this question. This term back of the envelope calculations does come up a lot. It actually means there are a number of calculations which are possibly too hard for you to do mentally, that you should be able to do quicker on the back of an envelope or a scrap piece of paper than it would take you to get out a calculator or your phone, find the calculator on it and do the actual calculations. So you should have a range of calculations that you can do quicker by writing it down than by finding a calculator and typing it in. And when is it important to get an exact answer, or when is it important to just know that you've got enough money at the supermarket, or when is it important to know that an estimate is good enough? So can you trust yourself on that? With subtraction, again, it might seem like an easy concept. Subtraction contains more conceptual misunderstandings and frequent and common errors than of addition. So again, it's something that you need to practice, be confident in, have a level of fluency and of course accuracy. So I'm going to throw some questions at you here. Now, multiplication is an extension from addition. So in fact, one of our most primitive definitions of multiplication is that it is a shortcut, shorthand way of dealing with repeated addition. 6 plus 6 plus 6 plus 6 plus 6, 6 groups of 6. So it's easier to deal with that through a multiplicative sense than it is in an additive process. So here are some things that you need to make sure that you're capable of doing, and you might consider practicing or revising or consolidating in your textbook with regards to multiplication. So using 2 different methods, so that might be the algorithm, a regrouping structure, a visual method. Particularly one that's really important to know here is the empty rectangle method. Can you explain all the notations that are used when completing a multiplication question using the formal algorithm? That's very important. Division is an inverse operation for multiplication. The idea of splitting something into groups so we can have partitive or quotative division processes, so into groups or how many in each group. So do you know enough basic facts about division to calculate and estimate efficiently? Of course, within that is knowing when to calculate and when to estimate. And can you explain the notations used in the formal algorithm? So that's either the longhand or the shorthand division algorithm. Still something you need to know. Can you explain it? And probably could you connect that to a sense-making approach, maybe using chunking or regrouping. Now, or surrounding all of this is, do you have the ability to make effective choices with regards to which method you're using? So it's very uncommon in real life to ever have a specific method required of you to complete a question. You're not going to be sitting at a coffee table with your group of friends and someone says, hey, can you calculate for me using long division what my share of the bill is? It's not going to happen. They might just say, what is my share of the bill? So what's most important is an ability to have a choice of methods. So I'm a very big believer about choice. So without choice, it's kind of akin to that old adage, you know, if the only tool you have is a hammer, then everything looks like a nail. So if you have choice, if you have different tools available to you, then you can be more effective in the method that you're choosing. That could improve your accuracy, your fluency, the effectiveness, and the ability to give good answers or appropriate answers. So it gives you power and reduces errors. So it's really important that you've got different ways. That's why through all of those operation slides I asked, do you have more than one way to do this? Because if you only have one way, then you've only got a hammer. So it's better to have a toolbox. Now, this semester, in this unit, every week you'll have what I call a learning brief. This is a one-page document that details all of the important information for the week's work. It tells you what to look at or think about before the lecture, tells you what the lecture will be about, what consolidation work you'll be required to complete, and that's, you know, the math stuff, the actual doing of the maths. Because, as I've explained, you can't actually get better and improve your efficiency and accuracy and fluency with skills without practicing them. What online videos or games or blogs or articles or activities I'm going to point you to for the week. Now remember that this unit requires you to participate fully. So that includes in the face-to-face workshops and also in the online work. I'm also flexible and human, so talk to me about any issues that you might have in completing work or attending. You can always work out a different way of being able to make up time if that's necessary. I'm unlikely to say, then don't do it, because it's really important that you do consolidate these skills. It's really important that we build your suite of mathematical understanding to a really high level by the end of this course, particularly on the topics that we're interested in, of course. So here's an example of the learning brief for week 1. So you see here the goals. This is something you should be able to come back to at the end of the week and tick off as things that you have achieved or that you understand or that you've completed. Before the lecture, some things to think about. Sometimes there'll be things to watch, questions to answer, or like a reflection of your current level of knowledge or understanding before you watch or come to the lecture. Just a little summary about what is going to happen in the lecture, the things I might discuss or things you might need to bring in terms of resources or materials. The practical components, so this is the things that you need to do. This is the practicing of the mathematics that's really important for your skills development. So this will detail the topics that you need to complete in your textbook and what hopefully you can achieve out of that. Here's an online component, so this week there are 2 videos to watch. I put here the time, how long they'll take if they're videos, just so you've got an idea about how much time you need. So yes, you'll fit that in on the bus, or yes, you'll fit that in before dinner. Just some people find that really helps. There's also a what's this section down the bottom. So this is an online component. It'll be completed in Leo, helps with your online participation, the questions to answer as well. I'll go into that in a bit more detail in just a minute. So this is just the one-page document, wraps it all up in a nice neat package. What do you have to do? You could go through, tick it off, highlight it. Some students find it really useful, especially as a reference tool, for example, leading up to your exam. So as you just saw on the learning brief, each week there's a section down the bottom there called What's This? So this unit requires you to participate both online and face-to-face modalities. The What's This component is part of that participation. So each week on that learning brief I detail an activity. It's called What's This? The question and form of answers will vary from week to week. You could be needing to answer a question with writing. You might need to answer a question with a picture. You might need to comment or contribute images or thoughts, ask questions or make an argument. They'll all be on Leo, be easy to find. You'll be able to tick it off, it'll get ticked off or marked as completed when you've met the required components. So Math Space, this is your required textbook for the unit. Details on how to register for it are on your unit outline, and I've got a short demonstration that I'll show you during this lecture. I need you to do this as soon as possible. Your first weekly task will be set for week 3 and it'll be using this textbook. So you need your own subscription and log in before then. You can't share one, you can't use someone else's because they only get a chance to do it once under their own login. It's really important that you've sorted this out before week 3 comes, especially because you need to learn how to navigate around using the online textbook, and you need to actually complete your consolidation questions because otherwise you've not practiced anything before your first mini test. So I'm just going to show you I'm just going to show you quickly how to register for your textbook. You go to mathspace.com.au, and then on the right hand side we're going to click Join In. At this point you need to fill in your details with your email address, and then create an account and type in a password. And click Sign Up. That'll register you. At this point, so now you're registered for a free trial, and what we want to do is upgrade. So what we want to do now is go to the place where we can actually subscribe. You pay the money to purchase the textbook, and then you're able to do the exercises as well as the assessment that I set you later. So to do that, just click on My Dashboard, and then it says to subscribe now, upgrade. So that's what we want to do. We want to upgrade this. Choose an upgrade. So from here we want Australian curriculum. That gives you access to all of the work that we'll need for this semester. And then you have a choice at this point. You can choose the $49.99 for 3 months, but I've organised to give all you guys 4 months, which gets us through to the end of the semester, or you could choose the $99 for a year. The main difference being obviously if you feel like you that mathematics is something that you need to work on, or that you would like to work on and practice to get better, then this gives you the opportunity to do that over the remaining of the year. But this will be the minimum requirement for you, so it's cheaper than most hard copy textbooks and quite powerful, interactive, and gives us the capacity to practice our mathematics with line by line feedback and working out. So once you've chosen whichever one you want there, go ahead, fill in your payment details and press submit, and then you're away. Very quickly, how to register for your textbook. Okay, now that you've registered for your textbook, I'm going to show you just very quickly how to navigate around it. Very briefly, just g'day. So once you've registered, this is the dashboard. This is the front page of one that you'll see after you've logged in. To access the work that we're going to be using mostly, you'll go into this All Topics section. So just click on that, and then all the topics will load up. Over here on the right hand side, you'll see my green bars. This is just highlighting the bits that I have completed or answered. It's like progress bars for each topic. So if we have a look in, for example, some directed numbers, and then within the directed numbers you've got all these little subtopics. These ones with the gold bar, that means that I've achieved mastery in those. I've achieved over a certain level, which the system defines as having completed with a level of mastery, and these ones I'm yet to complete. As I click on different subtopics that are available, I have a couple of options. For this particular one, I have a lesson, which is like the textbook. It explains what they are and the sorts of questions that you might need to answer. It's the theory. And then I've got the exercises, which are like in a typical standard printed textbook, the questions in the back of the chapter. I'll just show you very quickly the lessons. So then here's the theory component. We're talking about division of integers, so you've got some things to read, some examples that you could follow. Steps you through all the different types of questions you could get asked, and then we can go to the quiz from here. Or I can read more of the textbook, the previous section or the next section. Going to the quiz is the same as clicking on the adaptive exercise from the previous screen. So from this point I get questions that appear at the top here. I type in my work in here, or if you're lucky enough to be using it on a tablet device, you'll have a slightly different screen where you write your mathematics down the bottom of the screen. Along the top here is a progress bar showing you how far through the exercise you are. Now these exercises are all adaptive, so for some people, if you're getting them correct or you're finding it easy, you may only do 5, 6 or 7 questions. For other students who might get some wrong or have some misconceptions, or who take some hints along the way to get you going, you might end up doing 8, 9, 10 questions or even more. Each line of the question gets marked, so I can type in the question just as it appears there, 20 divided by 10, and that's fine, it's still correct. It's like the start of my working, I get an OK, I know I'm on the right track. I can complete my lines of working, or if I'm not sure what to do next, I can take a hint. These hints are a bit simple because the question is quite basic. This is helping me with the sign of the number, which of course is not necessary in this case because they're both positive. Once I'm ready, 20 divided by 10, type in my answer, and then I can move on. You can see that the progress bar has moved along. So as we continue through here, so this is the same as minus 54 divided by minus 6. I can see here that the negative signs might cancel out, so I might delete those. Still haven't finished the question. So 54 divided by 6 is, let's say I make a mistake and I choose 8. I get an incorrect step there. I can go back and take a hint, or I might be able to self-correct and go, actually no, I do know that the answer is 9. And I still get some progress, but it's not as far as it would have been if I didn't have an incorrect step. Now naturally, the system will want you to master each and every subtopic. So it'll want you to continue until you've achieved your gold grade or your mastery level, and that's the goal that we're going to have for each of our week's consolidation work, is to be achieving mastery of these topics. So like I said before, some of you might do 6 or 7 questions, some of you might do 10 to 15 questions. When you've achieved that mastery level and you've moved through and you've shown significant ability to complete the questions, you'll get your gold grade, and then at that point we can go back to the dashboard, or we can keep going and do the next one. So you can find how to get to your consolidation questions. Okay, so what next? Make sure you've registered for your textbook. Go to Leo. get the learning brief, complete your consolidation tasks in math space, complete your online components, so there are those 2 videos, and there's a forum on Leo that you need to answer. That is participation in lieu of the face-to-face workshop this week. Complete the what's this task. So there's a little bit of work there, a little bit of reading, a bit of self-reflection. How much of that whole number componentry do you need to practice? How much of the number theory should you go through? Do you remember what prime numbers are and composite numbers are? There's a lot in math space that you can really benefit from in terms of consolidating your tasks from Maths 1 that you may look at and go, oh, what was that? How do I have a look at it? Practice. It's very important that you commit to improving your mathematics skills over the next 12 weeks. Of course, I'll meet you all face-to-face next week. If you have any questions, queries, concerns, clarifications, my email address you'll be able to find in Leo. It's on the front page as well as on the unit outline. So all the best. Look forward to meeting you all soon.